In this question, you have to integrate log x plus 1 by x square into e raised to x dot dx. This e raised to x suggests that we have to use fx plus f dash x into e raised to x form. But if we consider log x as your fx, then we don't have its differentiation, which is 1 by x. So, to set the differentiation of log x, which is 1 by x, let's add and remove 1 by x. Your 1 upon x square will be remain as it is. Now for further simplification, let's split the term. This e raised to x multiply with log x plus 1 by x, and from the second term, if we take minus common, then we'll get 1 by x plus minus 1 upon x square into e raised to x dot dx. So, in first term, we get fx plus its differentiation, and whole function is within the multiplication of e raised to x. Similarly, in second term, we get 1 by x as your fx, and differentiation is minus 1 by x square. So we can say f dash x is also available within the summation. And we know that to integrate this kind of a term, you just have to ignore f dash x and your integration is done. Log x into e raised to x. And in second term, we have to ignore minus 1 by x square. So its integration will be 1 by x into e raised to x plus c. To get the answer within the option, we have to take e raised to x common. So we will get log x minus 1 by x plus c, which is given in option D. Ta-da! In this question, we have to integrate tan inverse x. We never like inverse t got up. So let's assume tan inverse x is equal to t. So you can get x is equal to tan t. Your dx will be sec square t dot dt. So we can modify our integration as this tan inverse x will become t and your dx will become sec square t dot dt. So here we have multiplication of algebra and trigonometry. So we have to assume t as a u and your sec square will be v. So let's apply integration by parts. In first term, your t will be as it is. We have to integrate sec square t, which is tan t, minus in second term we have to integrate differentiation of u, which is 1, and integration of sec square t, which is tan t dot dt. Now your first term will be as it is, and in second term integration of tan t will be log mod sec t plus c, but our answer should be in terms of x. So let's use our assumption to simplify it. Our tan t is x by 1. So if we use a triangle method, then let's assume this is your angle t. Tan t is actually opposite upon adjacent. So your opposite will be x and adjacent will be 1. So we can say your hypotenuse is x square plus 1. But as you know, we need the value of sec t. So let's find out the value of sec t. Hypotenuse, which is x square plus 1, upon adjacent, which is 1. So we are ready to convert our answer in terms of x. Your t will become tan t and your tan t will become x minus log mod your sec t, which is under root of x square plus 1 plus c. But we don't have to worry about this one. And this under root can be rewritten as x square plus 1 whole raised to 1 by 2. So your first term will be as it is, and in second term, if we apply the property of log, this 1 by 2 will come within the multiplication of log. So we will get 1 by 2 log x square plus 1 plus c. So tada! This is your final answer. which is given in option A. In this question, we have to integrate e raised to x by x into log of e into x raised to x. Now, before we go for integration, let's use the property of log to simplify. Log e into x raised to x, where e is a and x raised to x is b. So your e raised to x upon x will be as it is, and log a into b is simply log a, or we can say log e, plus log b, or we can say log x raised to x dot dx. Now let's apply the property of log. Your e raised to x upon x will be as it is. Now the value of log e is simply 1, and this power will come into the multiplication of x, so we'll get x into log x. Now let's multiply this 1 by x within the bracket, so we will get 1 by x plus x will cancel out and log x. So here we get e raised to x into fx plus f dash x form. And to integrate this kind of a term, we just have to ignore f dash x and your integration is done. So e raised to x into log x plus c is our final answer, which is given in option A. Ta-da! Here we have to integrate sine inverse 1 by x, or we can say sine inverse 1 by x can be rewritten as cosec inverse x. We never like inverse trigonometry, so we always prefer to assume inverse trigonometry is equal to t, where t is 0 to pi by 2. So here we can say your x must be cosec t. If we differentiate both the sides, we will get dx is equal to minus log t cot t dot dt. So we can modify our integration as this cosec inverse x will become your t, and your dx will become minus cosec t into cot t dot dt. Now we know the integration of minus cosec t cot t. So let's consider that whole term as a v, and your t will be u. So let's apply integration by parts. In first term, your t will be as it is, integration of v will be cosec t, minus in second term we have to integrate differentiation of u, which is t, so it will be 1, and integration of v, which is cosec t dot dt. So now your first term will be remain as it is, and in second term cosec t into 1 will be cosec t log mod cosec t minus cot t plus c. But our answer should be in terms of x. So let's get our assumption. Your cosec t is equal to x, or we can say x upon 1. So if we draw a triangle and consider this angle as theta, then cosec t, which is actually hypotenuse upon opposite, will give us hypotenuse as x and opposite as 1. So your adjacent sign will be under root of x square minus 1. So we can get the value of cot t from the triangle. Your cot t, which is adjacent upon opposite, sorry, we can say under root of x square minus 1 upon 1. So we are ready to convert our answer in terms of x. Our t will become cosec inverse x, and your cosec t will become x minus log mod this cosec t is your x minus your cot inverse t will be under root of x square minus 1 plus c. But our answer is not given in the option, so let's simplify. Your first term will be remain as it is, and we can say this coefficient will go within the power of your term. So we can say we have plus log of 1 upon x minus under root of x square minus 1. And to simplify this, we have to multiply and divide by conjugate of the denominator plus c. Still, your first term will be remain as it is plus log of, in numerator we will get x plus under root of x square minus 1, and in denominator we have a minus b and a plus b form, which will give us a square, or we can say x square minus under root of x square minus 1 the whole square, or we can say x square minus 1 plus c. So here x square will cancel out, minus minus will become plus 1. So we just have to ignore our denominator. So we will get x cosec inverse x plus log of x plus under root of x square minus 1 as a final answer, which is given in option A. Ta-da!